I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll learn about factoring polynomials. Here are the major topics of our interest. We'll start with some basic concepts to factor trinomials. We are going to take trinomials of the form x squared plus bx plus c. That is to say that the leading coefficient a is 1. We'll model two-factor trinomials. We'll work with sum and product with signs. We'll factor trinomials ax squared plus bx plus c where a is equal to 1. We'll also take up some cases where a is not equal to 1. Well, those are special cases where group factoring can be done. We'll see some examples where perfect squares are involved, and we'll have a communication and application question followed by an extended example. So let's begin with the basic concepts. So earlier we have learned that if I multiply two binomials, let us say we have x minus 3 times x plus 2, then what do you get? We can apply the distributive property to get the result. So first we'll multiply with x, then with minus 3, and see what do we get. Multiplying by x, we get x squared plus 2x, and then with minus 3, we get minus 3x minus 6. Now the like terms can be combined. So these are the like terms which we are going to combine. With the result, we get x squared minus x minus 6. Now as you can see, this can be written back as where we started from, which is x minus 3 times x plus 2. So it is a process which is kind of vice versa. When we went in this direction, we call it expanding, and when we came back, we call it factoring. So these are the two factors. They are called the factors. This is your polynomial. In this case, a quadratic function. You could also call this as a product of these two factors, right? So that is how they are related. Now let's also look into a model which will signify the given situation. So here we have green color which will represent all positive numbers. So on one side of this rectangle, we will just write down what it represents. Let us say this is x for us, and that is plus 3. So x units that long, and then these are units each. On this side, we have x plus 1 unit. So when you multiply them, what you get? You get right here x times x as x squared, and these are all 1 x's, right? So you can say x, 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 and x. So 4 x's, and these are your numbers 1, 1, and 1, right? So basically, what we're trying to say here is that when you multiply x plus 3 with x plus 1, what you get here is equal to 1x squared, 4x's, and the number 3. And that is the result which you expect when you distribute this and then simplify by adding the common terms. So basically, if I give you a model which is kind of like this, you can say that this rectangle inside could be produced by multiplying these two factors. So that is the concept, right? So if I give you the tiles as shown here in the center, you will know what made these tiles. So that is called the factoring. Let us take another example, and this time let's work it backwards. That is to say, we'll go from inside. Now here we have a result which is, this is x squared for us. This is plus x plus x plus x. Now, when we are putting in negative, blue color will write negative x. So this becomes negative x, and that is negative x for us. The other six numbers are negative ones. So these are all negative 1. So we have negative 6 here. Now this polynomial could be written as x squared plus 3x minus 2x and negative 6, right? So the blue color represents negative, the green as positive. Now, by simplifying, you get this as x squared plus x minus 6. And this can be written as product of these two polynomials. These two polynomials are x plus 3 and x minus 2. Minus because we are taking blue color as negative. So you can see that from the polynomial itself, we can get back to a factored form, right? So that is the factored form, correct? So in a way, we have done the factoring of the given polynomial in the form of tiles. Let's take up another example. The important thing here to note is that when you multiply negative with positive, you get negative result. Perfect. You'll also notice that as far as these units are concerned, which is minus 6, this minus 6 is basically product of these two, which is 3 times minus 2, right? So 3 times minus 2 will give you minus 6. That is the product part. On the other hand, you will also notice that the sum is the coefficient of x's. If I take these x's, we have plus 3x, and these two are negative 2x. Then when you combine them, what do you get? You get x. So we get this x right there, which is the sum of what? Sum of 3 and minus 2. Does make sense to you, right? And what we saw that the constant term which is here is the product, right? So in a way, we have an idea that sum and product could help us factor. We'll explore this idea further. So let's take another example and different combinations of negatives and positives. So let's write down what we have here. So in this case, we have x squared, which is positive. Let me write down this as x squared, which is positive. And then we have negative 1, 2, 3, 4, 5. So straight away, I'm writing negative 5x. As far as the numbers are concerned, we have positive 6. Perfect. Now this could be written as, from this side, we get x minus 3. And from this side, we get x minus 2. Now, what do you notice about sum and product? So let's see what is sum and product we had been talking about. Now, if I multiply these two numbers, which is minus 3 times minus 2, I do get plus 6. On the other hand, if I add minus 3 with minus 2, I get minus 5. You can clearly see that this minus 5 matches with the coefficient of x and 6 matches with the constant term. So that is what sum and product is. You get an idea. So basically what we're trying to say here is that if I have an equation which is x squared plus bx plus c, in that case we are looking for two numbers p and q. So if I add p and q, I should get the coefficient of x, and if I multiply p and q, I should get c. That is what it means. Perfect. So this is what we're looking for. So the idea to factor is to find out a right combination of P and Q, which when multiplied gives you a constant term and which when added gives you the coefficient of x. So let's master this technique of sum and product, and then we'll move forward to explore factoring further. So in this exercise, here is a question for you. Find two integers P and Q with the given product and sum. So we are given a set of products here, a set of sum. You need to figure out what these two numbers could be. Now I have chosen sets which will give you exposure to all possibilities. The first problem here is that we are given the product as 6 and sum is -5. Now how can you get 6 as your product? In that case, we could have P and Q. We are assuming that P is greater than Q. Magnitude of P is greater than magnitude of Q. That is what we are assuming. So, bigger number is P. So, when you multiply, you get positive number. It means both have same sign. If P is positive, Q has to be positive. And if P is negative, Q should be negative. But the sum is -5. So they have same sign and sum is negative. That means what? That means both are negative, right? So both P and Q are negative. Does make sense. So what the combinations could be? To get 6, we could do 2 times 3 or 6 times 1. Well, 2 times 3 with the negative sign works for us. So we could write this as negative, let's say 3 and -2. So when you multiply them, you get +6, and when you add, you get -5. So that is the correct combination. Is that understandable? Perfect. So let's try with the other combination. Now we'll have a product of -8, sum of 2. -8 is the product, means opposite signs of P and Q. Now sum is 2, that means P is greater, right? So P is positive and greater. Perfect. So P is greater than 0. P is positive. They are opposite sign. Q has to be negative now. Okay, we want -8. So 8 is 4 times 2. Sum is 2. So it is 4 for P and -2 for Q. That combination, when multiplied, will give you -8. When you add them, you get +2. Next one here is -12 and -4. -12 you get when you have opposite signs for the two numbers P and Q. Is that clear to you? As in the previous case. However, the sum is negative. Sum is negative means that P is less than 0. So the number with more magnitude is less than 0. How do you get 12 as a product? Well, 4 times 3, 6 times 2. Well, 6 times 2 can work for us, but 6 has to be negative. So -6 and 2 is what we are looking for. When you add -6 and 2, you get -4. When you multiply, you get -12. Now the last one is there for you. Both are positive. Both positive means that we are working with same sign, and now we have sum is positive. That means P is greater than 0. Q is also greater than 0. Both are positive, right? 18 is the product. 11 is the sum. 9 times 2 gives us the result. When you add them up, it is 11. So here is a very interesting exercise, and that is going to help you in factoring. I'd like you to pause the video, go through it, try to understand this concept, and then move forward. Now here is question number 2 for you, along with question number 3. Factor trinomial ax squared plus bx plus c, a equals to 1. So coefficient of x squared, the leading coefficient, is 1. We need to factor x squared plus 7x plus 6. What are you going to do? Well, we are going to look for two numbers P and Q, where the product of P and Q should be equal to 6. And sum of P and Q should be equal to 7. That is what we are looking for. So what combination could work for you? Well, 6 and 1 can work. When you add, you get 7. So 6 and 1 is the right combination. And so we can now write down the factored form, which is x plus 6 times x plus 1. And that is how we are going to factor it. As an exercise, what you can do is you can just verify. So I'll leave that for you as an exercise. So expand and verify the result. Is that clear? Let's do the next one here. Here again, we're looking for two numbers, P and Q, and we need to factor x squared minus x plus 20. What should be the product of these two numbers? Well, product should be the constant 2. And what should be the sum? Sum should be minus 1. What are these two numbers? 4 and 5. 4 and 5, yes. But see, we are now getting, if I write 4 and 5, I need minus 1 as my sum. But the product is plus 20. Both should be negative. If both are negative or both are positive, we cannot get minus 1. Do you see that? So this one here is not factorable. Do you understand why? So strictly speaking, you cannot factor all trinomials. So sometimes, or most of the time, with the question, you will also get a condition, if possible. So let me write down, if possible. So many times it is not possible to factor as it is in this particular case. Let me modify the question so that you could factor it. So I'm writing this question as question 3b for you to factor as x squared minus x minus 20. So if you write that, then you can factor. You could write this as negative 5 times positive 4, and that will be your result. Does it make sense to you? So the idea here is that always you cannot factor all the trinomials. Perfect. Let's move on and take the next question, which is question number 4 and 5 for us. Factor trinomials ax squared plus bx plus c, where a is plus minus 1. Well, I've specifically written because here we have an example which is minus 1. Here it is plus 1. Now, how can we do it? Well, same strategy. So again, we're looking for two numbers P and Q, perfect, where the product of P and Q should be equal to what? Minus 8, the constant term. And the sum of P and Q should be minus 7. The numbers could be what? Well, when you need product of minus 8, one is positive, one is negative. Sum of minus 7, bigger one is negative, right? So 8 and 1. So minus 8 and 1 can work for you. And therefore, I could write this as x minus 8 times x plus 1. You could verify these results. Perfect. Okay. Let's take another one, which is minus x squared equals to minus 5x plus 24. How are you going to do it? Well, here I would like to say that we'll do first group factoring. So if the coefficient is not 1, you could try to do group factoring if possible. Now there's nothing to factor. Well, you could factor negative sign. So we'll take negative outside and rewrite this as x squared plus 5x minus 24. Does it make sense to you? It is a good practice to factor minus 1. It helps. And now we'll go with our strategy of sum and product. I normally take product first and then the sum. Real reason for this is product has very few combinations, and therefore it helps for a quick result. So we are looking for minus 24 as a product. 8 and 3, 6 and 4, 24 and 1. These are the combinations. 12 and 2 is also a combination. So what works for you so that you could get 5 as the sum? Well, negative means opposite signs. So 8 and 3 could work. 8 has to be positive, 3 negative, so that we get positive 5 when we add them up. And therefore, Keeping negative outside and within the brackets, we get x plus 8 times x minus 3 as our answer. Does make sense to you? So here is a very important criteria. If the leading coefficient is negative, factor it out and then work with, as you work with normal trinomials where the leading coefficient is 1. It is very simple that way. Here we have two interesting examples. We need to factor trinomials ax squared plus bx plus c where a is not equal to 1. What I'm trying to say here is that the leading coefficient, as you can see, is 3 in the first case and 2 in the second case. Now, if we are applying the strategies which we have just learned, what should be done? Well, the idea here is to factor what is common. 3 is common in all, so we could do group factoring. Does it make sense to you? So we can factor out 3, and if you do that, you get x squared minus 2x minus 8. So dividing each term with 3. Now, we have 3 outside and x squared minus 2x minus 8, where the leading coefficient for x squared is 1. And so we can use the techniques learned. The technique learned was product and sum. We're looking for two numbers p and q whose product should be the constant minus 8 and whose sum should be how much? Coefficient of x, which is minus 2. Now both are negative. That means we're looking for two numbers. Bigger one is negative and the smaller one is positive. 8 and 2. 4 times 2 can work for us. So minus 4 and 2 can work for us, and therefore we could now factor this and write this as keep 3 as such and factor the inside term as x minus 4 times x plus 2. Does it make sense to you? I'd like you to have a good look at it. Try to understand the concept, expand, simplify, and verify. That is the job left for you. Okay, let's do one more question here, which is 2x squared plus 6x minus 20. At this stage, I'll appreciate if you could pause the video, solve yourself, and then look into my suggestions. So first step, factor the common term 2, and we get what? We get x squared plus 3x minus 10. Divide each term by 2. Now, we're looking for sum and product, where the product is first thing to do. Product should be the constant, which is minus 10 now, and sum, the coefficient of x, which is 3. The two numbers which could work for you could be what? 5 and 2, for sure. Now, we need positive 3 as a sum. Product is negative. One number has to be negative. Perfect. So we could write this as 2 times x plus 5 times x minus 2 as our result. That is the answer. So what you need to do here is expand and verify. Let's take up two more examples here on factoring techniques. Perfect squares introduction. So you'll find a very interesting case here. This question seems to be very simple. X squared plus 2x plus 1. You need to factor it. So, okay, pause the video, factor and see what is so unique about it. Again, we're looking for two numbers p and q where the product p and q should be 1 and the sum of p and q should be 2. Well, there is only one combination which can work for you, which is 1 and 1, and therefore you could write this as x plus 1 times x plus 1. You have exactly the same factors. Do you see that? These two numbers which we got are 1 and 1. So you get the same factors. The result, therefore, is what? It is x plus 1 whole square. So that is a perfect square. So when you see that both the numbers which are p and q are exactly same, we land up with perfect squares. Next one here is x squared minus 6x minus 9. In this case, again, let's see what is the product and what is the sum. The product should be minus 9. Sum should be minus 6, right? Sum should be minus 6. That is p plus q should be minus 6. The two numbers could be what? 3 and 3, right? So if I write, well, one of them has to be negative, The other one has to be positive, so this won't work. Because when I multiply -3 with -3, I'm going to get 0, +9, and then it will not work, right? So now what can we do about it? Well, this one is a typing error, or you can say it cannot be factored. Perfect. So what we will do here is we will actually change this question. I will actually write it +9 here. So this was a typing error. So we'll say product of +9 and sum of -6. Okay. So what I did here was change the question to x squared minus 6x plus 9. Okay. So the product should be +9, sum should be -6. The two numbers in this particular case are -3 and -3. So when you multiply -3 by itself, you get +9, and when you add them, you get -6. And therefore, we could write this as x minus 3 whole square. You get the idea. So you could factor x squared minus 6x plus 9, and what you get is a perfect square. So that is what we meant by Introduction to Perfect Squares. We'll actually explore this in greater details in coming videos. Here, for now, we've understood that when you are looking for product and sum, you may land up with same numbers, which are in this case 1, 1 and -3, -3. In that case, we land up with perfect squares. Is that clear to you? Okay, so let's take some more examples, and this time we have question number 10 and 11, which are very interesting, and such questions can be seen in test problems, especially in thinking and communication section. I'd like you to pause the video, think over them, answer, and then look into my suggestions. Determine two values of b so that each expression can be factored. Question number 10, x squared plus bx plus 15. Question number 11, x squared minus bx minus 12. You need to find the value of b so that you can factor. In previous examples, we have seen that there are situations where you cannot factor a trinomial. Now, why was it so? Because we could not get the right combination of product and sum. So now let's look for product. Product of two numbers p and q should be this constant value of 15, and the sum of p and q should be the coefficient which we are looking for, b. Now let's see what numbers can give us 15. Well, 5 times 3 can give us 15, and when you add them, you get 8, and therefore b could be 8. Does it make sense to you? We need more combinations. Well, 15 times 1 is also 15, and when you add 15 and 1, what you get is 16. So b equals to 16 could be another combination. So that is how you can easily find the answer. Apply this strategy and give me the answer for the next question, right? Okay, here again, we are looking for product and sum. Product should be -12 and sum should be equal to -b. Let's take two numbers, which could give you the result. -12 means one number should be positive and one number should be negative. That gives you -12. When you add them up, you get +1. Well, minus b is +1, so b is equal to -1. Does it make sense to you? Because here it was -b, so that is very important to note. Perfect. Let's have another combination, and this time I'll take bigger number as negative, so -12 we could get by -6 times 2. Now when you add them up, then what do you get? You get -4. So minus b is -4, that means b could be equal to 4. So those are the two answers for you. Perfect. Have a good look at it. This is a very useful question from test point of view. Now let's take up the next example, which is similar to the last one with a main difference, and that is determine two values of c, this time the constant, so that each expression can be factored. How are you going to do it? Well, we'll work it the other way. We'll begin with the sum of two numbers p and q, and we'll find the product. Do you get an idea? We know the sum is given to us as 5, and what numbers could give us 5? This is what we have to figure out. Well, 5 you could get as 3 plus 2, but when you multiply, you get 6. So C should be equal to 6 in that case. You could also get 5 as 4 plus 1, which is 5. When you multiply, you get 4. So C could be equal to 4 also. Likewise, you can have many combinations. Perfect. Let's do the next one. Again, as I said, we have to look for what we are given. We are given the sum this time, P and Q. When you add them up, it is minus 1. C is the product, right? So P times Q is C. What could add to give you minus 1? Well, minus 3 plus 2 could give you minus 1. No problems. When you multiply, then C should be equal to minus 6. So C equals to minus 6 is one combination. The another combination could be minus 4 plus. If I write minus 4 plus, let me write 5 here. What we get is not minus 1, but we get plus 1. So that is not the right combination. You get an idea, right? So the bigger number has to be more negative. Let's say minus 10 and 9, right? So, and 9. So when you multiply, you get minus 90. So minus 90 could be a combination. But C will be equals to minus 90. That is the next way, next combination. Likewise, what you realize by now, there could be infinite values of C if we are given the sum and we need to find the product. So I hope now you realize why we were finding products first, because there were limited cases. Perfect. Now let's look into the application question, height and distance. It is the most common application question seen in every test paper. Question number 13 here is, height h in meters of a ball thrown from the height of a building is modeled by the function h equals to minus 5t square plus 25t plus 30, where time is in seconds. How long is the ball in the air? Hmm. How do we do it? Well, let's try to visualize the situation. We are throwing something from top of the building. It will take a projectile path and land on the earth. So how long means this long. So we need to find when will this height be 0. That is what we need to figure out. How could we do it? Well, factoring really helps in this. So we have height h is given to us as minus 5 t square plus 25t plus 30. Since we have something minus 5 here, let's factor this out. So we have here t square dividing by minus 5 gives us minus 5t and minus 6. Now we can apply a product and sum strategy to factor this. Product of two numbers, we want the constant minus 6, and the sum of these two numbers should be minus 5. 3 and 2 can work for us, right? So we have the combination of 3 and 2. So that can work. 6 and 1 can work, because 1 has to be positive, 1 has to be negative. Opposite signs, correct? So minus 6 and really 1 can work, not 3 and 2. Minus 6 and 1 will work. So we get minus 5 times t minus 6 times t plus 1. That is going to give us the result. Now, how do we get the answer to the question, how long is the ball in the air? So it is till height is greater than 0. So as soon the height becomes 0, we get this time when it lands on the ground. So that is the time. So we'll now equate height to 0 to solve this particular equation. Now height can be 0 if t minus 6 is equal to 0 or t plus 6 is equal to 0. So t minus 6 equals to 0 gives us time t as 6, which is 6 seconds. T plus 1 equals to 0 gives us time t equals to minus 1. Well, in any application question like this, you'll have to assume that time t is greater than or equal to 0. It cannot be negative, as you can see here. So this is our time t, right? So this is not valid, but this is correct. So this is, we say, not valid, right? Or does not exist in this particular case, and therefore Our answer here is duration of time is 6 seconds since it starts from 0 and then for 6 seconds the ball is in air. Does it make sense to you? That is how we are going to solve it, and whatever I explain is important to write down to get full communication marks. So this is normally taken as a communication and application question. Perfect. So let's move on and take the next example, which is the last question of this particular video. It is kind of extended since now in question number 14 we need to factor x to the power of 4 minus 4x squared minus 5. How am I going to do that? Let me rewrite this expression, which is x to the power of 4 minus 4x squared minus 5. This is not quadratic, degree 4. Well, let's do a substitution. Let's say we have something like t equals to x squared. In that case, t squared will be x to the power of 4, and I can rewrite this question as t squared minus 4t minus 5. Have a close look at it. We have reduced this particular equation to a familiar form, which is our quadratic form. And now we can apply the product and sum strategy. So we are looking for factoring t squared minus 4t minus 5. So we need product of two numbers to be minus 5 and sum of two numbers to be minus 4. The two numbers could be what? 5 and 1. 5 should be negative and 1 should be positive, right? So we have 5 and minus 1. That works. And therefore, we could write this as t plus 5 times t minus 1, right? No, the sum is negative, so the bigger number is negative and smaller number is positive. And therefore, this is not what is expected. It should have been, yes, it should have been t minus 5 times t plus 1. Perfect. Now substitute back t as x to the power of 2 here. So we get x squared minus 5 times x squared plus 1. So that becomes our result. And therefore now we can write down the answer, which is x to the power of 4 minus 4x squared minus 5 can be factored and written as x squared minus 5 times x squared plus 1. Does make sense to you? So that is how we are going to factor it. I hope you find this set of questions interesting and useful. See, there are many places where you may go wrong. So we did go wrong many times. You have to really take care of it. And remember, product and sum is key to answer all these questions. So we come to an end of this particular video. I hope you have learned many techniques in factoring trinomials, especially when the leading coefficient is 1. There could be times when the leading coefficient is not 1. You could factor it and then apply product and sum. So product and sum is the key to factor trinomials when we are working with situations given here. Also remember that all trinomials cannot be factored. The only ones where you have right combination of integers giving you product as same as constant and sum same as the coefficient of x, only then a trinomial can be factored. I hope with this you understand and appreciate what we have done. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best.